Before we start talking about a traversal, we're going to look at two quick definitions. We're going to define a stack and a queue. A stack is a sequence of elements such that each new element is added onto one end, called the top, and an element is removed from the same end. So you can think of if you put something on the stack, then you would have to take it back off the stack, rather than pull something from the bottom. The other definition, though, of a queue accounts for the different case. A queue is a sequence of elements such that each new element is added to one end, called the back of the queue, and is removed from the other end, called the front. So this is more like what we would say if we were in line. You get in one side and you come out the other. Now, in designing computer algorithms, stacks and queues have been used for traversing trees. But since we're not a computer, we can be much more intuitive, and so we are going to look at how we can traverse a tree using its recursive properties. The first one that we're going to use is the pre-order traversal. In the pre-order traversal, we're going to visit the root first, then the left subtree, then the right subtree. In a post-order traversal, we'll visit the left subtree, then the right subtree, then the root. And finally, in an in-order traversal, we visit the left subtree, the root, and then the right subtree. So what makes it pre, post, or in? Notice it's when we visit the root. If it's pre, then we visit the root first. If it's post, we visit the root last. And if it's in order, we visit left, and then the root in the middle, and then the right. So let's take an example where we're going to traverse a binary tree, and let's visit the root first. So this is going to be a pre-order. We'll visit the root, then the left subtree, then the right subtree. So the root is 2, so the first vertex that we actually visit is 2. Now we want to do the left subtree. The left subtree, what we're going to do is visit the left subtree in the same pre-order, which means we visit the root first, then the left and right subtrees respectively. So when we go to the left subtree, we'll visit and record a 7, which is the root of the left subtree. Now we go to the left subtree of that, which is 2. So we visited the root in the left subtree. Now we go to the right subtree of 7. Since we're visiting the root first, the next thing we record is a 6. And then its left subtree is 5, and its right subtree is 11. So what we have done is we visited the root and the left subtree of the root, using the same root, left, and right order. So now we would go to the right subtree of 2. Let's take a larger tree for our next example. Remember, this is still pre-order, so we're still going to visit the root first. So the first is 60, and now we're going to do the left subtree. Looking at the left subtree, its root is 41. Now we're going to do its left subtree. Looking at 41's left subtree, its root is 16. It doesn't have a left subtree, so we go to its right subtree, which is 25. And we say, where are we? We have visited the root and the left subtree of 41, so now we need the right subtree of 41. Its root is 53, so the next thing after 25 would be 53. Now we want the left subtree of 53. Its root is 46. And then we want the left subtree of that, and its root is 42. Now where are we? We visited the root, which was 53, the left subtree, now the right subtree. So after 42, the next one is 55. Now where are we? We did the left, we did the root 41 in both its left and right subtrees. So now we go back up. We did the left subtree of 60. Now we want the right subtree of 60. And its root is 74. Its left subtree, its root is 65. Its left subtree, its root is 63. Its left subtree, its root is 62. We go back up, we did the root 63 previously, and we did its left subtree. So after that, we need the right subtree, which is 64. We back up. We've done the left subtree of 65, so now we do the right subtree of 65. So after 64, we would get 70. We have to keep using this recursive structure. Each time we visit a tree, we do its root, its left, its right, and then back up. Now let's do a post order. That means we'll visit the root last. So we look at this tree. We don't want to start with 60 this time. We want to start with the left subtree. But it in turn is a tree. So we don't want to start with its root, but we want its left subtree. So its left subtree has a root of 16. We want to start with its left tree, but it doesn't have a left tree. So now we'll do the right tree. So the very first vertex we actually visit is 25. There was no left. Its right is 25, and its root is 16. So we have 25 and 16. That's the left subtree of 41, so now we want the right subtree of 41. Its left subtree will take us all the way down to 42. So we'll have 25, 16, and then the next one we visit is 42. That was the left tree. There is no right subtree of 46, so we come back up to its root, which is 46. This means we visited the left subtree of 53. Now we want the right subtree of 53, which is 55. And now that we've done left and right of 53, we can finally say 53. And now that we've done left and right of 41, we can now say 41. We've only done the left of 60, so now we need to go and do the right of 60. We'll do the same thing on the right that we just did on the left, and then the very last one that we will visit is the root, which is 60. Left, right, and root. And of course now the in order, where root is in the middle. Left, root, and then right. So looking at this one, we want to do the left subtree first. But looking at the left subtree as a tree in its own right, we want to do its left subtree first. So we would begin with 1. There's the left, root, and right. So we would have 1, 3, and now the right subtree. The left, root, and right will give us 4, 6, 7 there. So it starts off 1, because that's left, root, which is 3, and right, which is 4, 6, and 7. What will be the next number that we write down? If you saw 8, you're right on, because we had just done the left subtree of 8. And since root is in the middle, left, root, and right, once we concluded with 7, we can now say the root, which is 8. And then the right subtree. Root, left, and right. Since we do not have a left subtree for 10, we can go ahead and say 10 and do its right subtree. 14 and 13, we say left subtree first and then root. And this is the order that we would visit the vertices if we were doing left, root, and right.